So this is a question from one of the students related to one of the chapters based on the contribution margin and break-even analysis. And so this is Barclay Bikes manufactures and sells 3 different styles of bicycles. We have the youth model, the adult model, and the recreational model. This is how I read it. Whenever you're looking at a question like this, here's a quick pause. Let's not agree. There's so many facts and circumstances. The way I approach it is first, what are we trying to determine? We're trying to determine break-even analysis, break-even point. So now that we know the break-even point, what do we need to know? Well, we know we need to know what sales are per unit, what the contribution margin is per unit, and then since there's a sales mix here, we need to know the sales mix. And so then everything else here is, I can skip through it. This way I can work through the question a little quicker. It's okay, we have model 1, it's $300 at a contribution margin of 105 and a sales mix of 5 models. Model 2, adult, is 850 sales, 450 contribution margin, and then 9 adult models is the sales mix. And the recreation is 1,000 sale, $500 contribution margin, 6 recreation models. And then what are we saying here? So we're saying that our sales is the total amount we're going to charge and receive for these bikes. The contribution margin is once we remove the variable costs, right? Direct manufacturing, direct labor, variable overhead. We remove it, we get our contribution margin, and the remainder is the contribution margin, the amount that we can apply towards our fixed costs in the future. And then our sales mix is saying for every 5 youth models, we sell 9 adult models and 6 recreation models. And so easiest way to do this, and I'm allowing you to use these on your quiz, is just build it into a sheet. Right, build it into a sheet. So we go here, 150, I'll zoom in for you. And so I just put in these inputs, youth, adult, recreation, price, contribution margin, that's what CM stands for, and the product mix. And then this is just the multiplication, you just multiply it out. So we're saying, if we were to sell 5 youth models, we'd make sales of 1,500, which is just the price times the mix, and a contribution margin of 525, which is the contribution margin times the mix. Same thing, adult, we multiplied it out. Recreation, we multiplied it out. And then per one of the sales mix, so if we sold this whole group, we'd make $15,150. And our contribution margin would be $7,575. So we have a 50% contribution margin on the sales mix. And then there's 2 ways to calculate this. We just take our fixed costs and divide it by the 50%, which is also multiplying by the 2 to get to our 13 million. Or another way we can look at it is we have one of our sales mix here makes a $7,575 contribution margin. Our sales mix, we need to sell 858 sales mixes. The way we got that is one sales mix is 7,575 contribution margin, and we need that amount to cover our fixed costs. How many of those mixes do we need to sell in order to cover our fixed costs? Well, we need 858 of those. And the way I can get that 858 is by taking the 7,575, that's one sales mix, the sales mix being 5, the 9, and the 6 of these models, divided by the fixed costs. And then I just multiply this by the revenue. So we took our revenue per sales mix, one sales mix, and multiplied it by our 858 sales mix needed to sell. And we also get 13 million. So the answer here will be 13 million. And so I've shared this model with you, and you can use this for any contribution margin or break-even analysis. So I'll stop there. Any questions related to this? Is this helpful? I'll jump to questions really quick.